Welcome everyone. So my topic today will be about anatomy of a cyber attack. I want to show you how you can make forensics simple with the power of artificial intelligence. So before I start with the topic, I will just show you a little bit about the current threat landscape that we are facing. So my colleagues in the labs came up with the newest results, which malware types we are facing nowadays. And as you can see, the old traditional malware, which we call generic malware, only accounts for about 2% nowadays. So these were known malware variants. And today we are facing a lot of malware that we categorize as modern malware, meaning that this malware is using combinations of exploits, typically known exploits like we have seen in WannaCry. They're using privilege escalation technologies, they will try to steal your passwords, and they are combining all these mechanisms to achieve their goal. Then we also have something called ransomware, of course. Everyone knows ransomware. It's still popular because it guarantees the bad guys that they will really, really fast get cash back. And because of the power of the cryptocurrencies, they can get it in an anonymous way or nearly anonymous. So that's a big advantage for the criminals, and therefore we also see another trend that's called cryptojacking. So the bad guys will use your resources. We had some cases where they took over AWS accounts, so cloud accounts, and they just spin up a few instances and mined cryptocurrency with your resources, with your money, and they made cash with it. So this is how dramatically the threat landscape shifted, and the last thing that we are missing is the 5% zero-day malware, so the malware that we didn't see in any kind before, which typically also makes use of some unknown vulnerabilities and exploits those. So how to protect yourself against these mechanisms or these malware types? Well, one option is of course to go with a traditional endpoint protection. So you install the endpoint protection solution, and then when are you protected? Well, it depends if your organization is one of the first ones to be attacked or one of the last ones. If you're one of the first ones to be attacked, you don't have big chances to protect yourself. That's a big problem, because modern malware really circumvents traditional endpoint protection solutions. So if you're one of the first ones to get attacked, you're in trouble. Otherwise, your endpoint protection vendor may have published something that may help you. So therefore, you see a little bit green, but still a lot of red. And especially when talking about the zero-day malware, you are really in trouble with traditional signature-based solutions. Therefore, the IT security industry came up with a new term, with a new solution, and that's the next generation endpoint protection, meaning that we are using technologies that protect us against exploits, against ransomware, and therefore the protection scope looks much better, of course. Much more green that we see here, but never forget we still have a little bit red over here. Why? Because in IT security we will never have 100% security, so we will probably have like 99.9 or 9.8, but we won't never achieve 100% security with one solution, and therefore we need to follow this defense in depth approach by combining several technologies that protect me. So let's sum it up, the evolution of the endpoint technologies. Well, in the past, we relied on technologies like endpoint protection, which combined signature-based detection with device control, web control, and similar technologies. Then we also had in the past, or now yesterday, I will call it the next generation endpoint I just talked about. So this combines machine learning technology, ransomware protection, exploit mitigation, but it's still not enough nowadays. Why? Because we need to protect against hackers, we need to protect against advanced persistent threats. And how to do this? For this we have a new product category, and that's basically the EDR, so Endpoint Detection and Response. This is a holistic, integrated approach of endpoint security, focusing on a detection and a containment of these threats. And combined with all the previous technologies, this gives us the best protection we can get nowadays. So just to clarify what EDR is a holistic approach to integrate security technologies on endpoint, meaning we want to detect security incidents, we want to react to those incidents, of course, and we also give you the ability that you search for these threats on all of your machines, endpoints or servers. And finally, we need a forensic investigation to make sure what happened during the security incident. And, well, why should we use these tools? I guess here's a lot on the slide, but I guess the thing that most matters is 4 letters, it's GDPR. We need to make sure that our data is safe. We need to make sure that nothing is leaking my organization. And these tools will give me the insight what really happened during a compromise. Did we lose some personally identifiable data or not? And we will always see what a hacker exactly did in my network, how he moved in my network, so I can basically the next time even, well, strengthen my defenses that I have. So a few quotes on what or how the EDR is helping customers. First of all, it will tell you, am I under attack currently? It will tell you if the threat is over or if the threat is spreading within your network. It will tell you if you are out of compliance or not, and it will give you an idea what to do next. So it will highlight an indicator of compromise. It will tell you, listen, you're under attack, and we tell you what you should do to stay safe with our solution. And, well, how we are doing it? We are doing it with artificial intelligence. Every vendor claims to be using artificial intelligence, so just a few slides giving you an idea why we should use artificial intelligence and how we are using it in our products. Well, first of all, we want to have predictive security, and we need this predictive security to stay safe, of course. We have seen just before me, the colleague who presented how many threats we are facing. We are facing 100,000 new malware variants every day. So we need predictive security, but also predictive security that's based on a knowledge that we collected in over 34 years of IT security experience in Sophos. And we are using this to give you better protection, better performance, and better accuracy. We do not want to have any false positives, of course. So, talking about artificial intelligence, to be honest, nearly none of the vendors really use artificial intelligence at their products. They're using some sub-region of it. It's typically called machine learning. So we are giving, or we are building machine learning algorithms that can tell me if something is malicious or not malicious. We, in our case, are using deep learning. That's advanced form of neural networks, meaning that it's modeled after the human brain, and this model is fed with all the information that we collected in all the years that we are in IT security, and now has the ability to basically predict if something is good or bad. So why did we choose this? Well, we have machine learning a long time already in IT security. We had in the 80s already, in the 90s, we were using things like decision trees, random forests. These were state of the art back then, but nowadays we have neural networks, so deep learning based on these networks. And before, when I studied like 10, 15 years ago, we simply did not have the computing power to train these models appropriately. Now, thanks to the cloud, everyone has the computing power. So we built this model because it simply performs better than the traditional machine learning approaches. So what are the big things or big advantages that I'm talking about? Well, first of all, typically traditional machine learning gets worse when we feed it with a lot of data. Our deep learning algorithms gets better and better the more information that it gets. Like the human brain, the more I learn, the better I get, of course. It's pretty fast, so we only have a few milliseconds giving me a detection if something is good or bad. And it's pretty small, so it's like 10, 20 megabytes, so we can fit it on every endpoint or on every network appliance that we have in our product line. So where do we have this machine learning algorithms? We have it, first of all, we introduced it with Intercept X for endpoints and servers, that our endpoint protection solution, integrating the power of machine learning with all the other protective features. And we have it also in our sandboxing technology. So we have it, the clicker doesn't work anymore. Ah, yeah, now, okay, thank you. So we also integrate it in a sandbox, meaning that whenever something passes through our network appliances, we can check if this is good or bad. And the next logical step was for us to integrate this machine learning, this deep neural network in a solution that we want to, well, offer you to make forensics easier. So we integrated this in our EDR solution, so leveraging the power of machine learning to make analysis much easier than it was before. So How does it look like? I created like 2 or 3 demo scenarios over here. So first of all, this is a threat case. So this is created automatically by our solution whenever your system is attacked. In this case, we can see there was a client, the root cause was Outlook, we had some ransomware exe running it, and we cleaned everything up. Perfect. Then we will give you the insight. We will tell you, okay, listen, Outlook was opened. We have written a Word document down here. Microsoft Office opened a PowerShell. That's kind of strange. Downloaded some self-extracting archive. And then finally over here, you wanted to encrypt my files. So now you exactly know the kill chain or the attack chain of this malware and what happened to your network. But of course, we want to have more insights. And this small example is a root cause created by an Emotet attack. Emotet was quite notorious in the last month, so everyone knows it typically. So this is how it looks like when Emotet moves on the system. And the interesting thing is over here. So Emotet opens a network command shell, and we can even with our solution see what Emotet is doing. So in this case, Emotet was basically using the command shell to delete a firewall rule that's used for remote assistance. So it's blocking the administrators of getting to the system. And then we also have the machine learning analysis. So whenever you stumble upon a file that's kind of strange, our machine learning analysis will give you an insight what we think, what our advanced algorithm thinks about the software. So it will tell you, okay, the attributes look suspicious because it is obfuscated, encrypted, whatever. So we examine everything and give you also the indicators. We see it a lot in bad files or in good files, this attribute. We will give you the idea about code similarity. Does it look like just another ransomware we have seen before? And also the file path. And then you can, with the click on the button up here, you can basically say, okay, search for this on other systems, or block it completely in my environment. So block this file on every machine and remove it from my machine. So that's the power that we give you. So even if there's some gray space in between, it's not 100% bad, we can still give you an indicator that it seems to be something malicious. The search for these elements looks like this. So you can just paste a hash down here in a search field. You can paste an IP address, an URL, you can look for PowerShell commands, and it will tell you, okay, listen, this was found on these boxes. You can even see the complete network communication that's happening out there. So this is the detection part that I've shown you now. So since I have only a few seconds left, let me talk about the containment of threats. That's also important. So we want to prevent that the threats are spreading within the network. How to do that? Well, we have one feature that's called the self-isolation, meaning that whenever an endpoint spots something suspicious happening on his box, so something strange is running, some strange processes, then we are capable of isolating this endpoint, meaning the endpoint is not able to communicate anymore outbound or inbound. It's completely isolated until we clean up the mess. The other scenario that we have is, of course, when the administrator, for example, wants to examine something strange happening on a box, he will simply push the isolate button, and then we are capable also of isolating this machine and can therefore protect all the other machines connected to this network. So my last slide that I have is just an invitation. We will have also a workshop where I will show a few things. The clicker doesn't like me, or I have too many presentations. There we go. So one slide that I want to show you is the invitation to our workshop, meaning that I will have a presentation happening in the one floor down, where we will have an EDR in action showcase. So we will run our EDR solutions. We'll do like a little life hack. I will show you what you can learn with our solution, and I will also show you how to protect your other systems with a concept that we call synchronized security. So thank you very much for listening, and I hope some of you will join my workshop. Thank you very much.